Okay, section 3.3 is on page 184. It talks about the law of cosines. Again, I'm going to upload the PDF file for these notes so you could view. You no need to rush to copy down. You could always just download the PDF form and go from there. So, suppose we have a triangle. And if I want to call this angle A, this side A, angle B, this side B, and angle C, and this side C. They like to capitalize those. If I draw a perpendicular line coming down, looking from A's point of view, so this side right here is all C. If I call this X, and I call this Y, if I look at this angle A, as far as this triangle is concerned, if I take the sine of A, that would be the Y, that would be the opposite over the adjacent. I'm sorry, the opposite over the hypotenuse. So pretty much Y is B times the sine of A. And if I look at this problem again and proceed with the cosine of A, that would be the adjacent, which is X over B. And if I cross multiply, X would be B times the cosine of A. Now, if I look at the second triangle, if I take this is a right triangle. If I mimic that right here, this is angle B, this is Y, and this length right here, would be C minus X. And this is, of course, still side A. If I take A squared, that would be Y squared plus C minus X squared. So A squared would be, and if I replace Y by its value, which is B the sine of A, right there, and if I replace X by its value, which is B the cosine of A, I would notice that A squared equals, look at the squared, B squared the sine squared of A, plus C squared minus twice C times B the cosine of A, plus B squared the cosine squared of A. A squared would be, if I combine those two, factor a B squared out of those, I would have a sine squared of A plus cosine squared of A plus C squared minus twice CB the cosine of A. And we know what cosine squared plus sine squared of an angle is. That would be 1. And that's pretty much it. This is A squared equals B squared plus C squared minus twice BC the cosine of A. And that's the law of cosine. Similarly, I could say, so the way it works, if I go back to the original triangle, without any of the additions that I made, basically given any triangle now, what this is saying is, if you take A squared right there, that would be B squared plus C squared, sort of like the Pythagorean identity, except there's an added piece, minus twice the sides b times c times the cosine of the angle opposite of a. Similarly, if I pick b squared, that would be a squared plus c squared minus twice ac, the cosine of the angle opposite of b. And if I was to pick c squared, that is a squared plus b squared minus twice ab, the cosine of the angle opposite of that. And that's pretty much the law of cosine. Now we want to practice some problems. And let me start with an example. Directions. Solve each triangle. In our book, this would be on page 188. I'd like to start with problem number 10 for starters. And I do want to note a couple of things. One, this is not a right triangle. So a common mistake students do, they say that's 30, they think, oh, 30, 60, 90. That's not true. That's no longer the case. And second thing I want to point out, the law of sine wouldn't work on this problem if you notice. If I'm thinking, well, I'll take the sine of 30 to a, there is no other known angle. And the law of sine would be useless. It would be challenging. So instead, if I picked the angle given and the side opposite of that, and if I was to say a squared is 3b squared plus 4 squared minus twice 3b times 4, the cosine of 30 degrees, I could figure out what this equals. This is a value. If I plug this in my calculator, a would equal 2.05. And I'm going to show how to do that just for one problem. And if I take, this calculator works backwards. If I take 30 cosine multiplied by 4 times 3 times 2 equal, make it a negative, add to it 16 plus 9, and if I take the square root of that, I will get 2.05. How many decimals should we keep? Well, 2 decimals are sufficient for what we need. That's fine. And now that I know that this side right here is 2.05, I could either use the law of cosine to finish the problem or just use the law of sine. That is, I could say, now that I know this, go sideways. If I say now, you know what, I'm going to take the sine of b to 3 equal the sine of 30 degrees to 2.05. I do want to also talk about this a bit. This is 3 times the sine of 30 degrees divided by 2.05. And that would be either 47.03 degrees or 132.97 degrees. Remember, every time I use the law of sine and I get a value, I am either in quadrant 1 or in quadrant 2. Now, I know automatically it can be this case, and that's the point I wanted to mention. You notice when I found angle B, I picked the side opposite of the smaller side, which means that angle cannot be the biggest angle. Since the 3 angles in a triangle add up to 180, only one angle could be 90 or more. The other 2 angles can be. And since I'm picking 3, which is smaller than 4, angle B has to be or must be smaller than angle C. which indicates that it can be an obtuse angle, it must be acute, and that's how you avoid this case every time. So it doesn't matter which side you pick first, so that you wouldn't get the two triangles like we did in section 3.2 and worry about the ambiguous case. And once I know that this here is 47.03, well, we know how to get the third. We'll say, well, angle C must be 180 degrees minus 30 degrees minus 47.03 degrees, and angle C would turn out to be 102.97, like I mentioned. When you're done, like we checked in the previous section, the biggest angle should be opposite of the biggest side, and the smallest angle should be opposite of the smallest side. And there it is. That's how we do this. Again, I'm going to point this out as I do other examples of which angle to pick first to make sure that this ambiguous case doesn't come up. I want to look at another example, and let's say I want to look at number 14. And again, when dealing with this, again, the law of cosine cannot help, the law of sine cannot help me on this problem, again, because I need an angle out of those. If I'm going to pick an angle, I would definitely not go for angle A. I would either go for angle B or angle C. Now, if I'm using the law of cosine, you'll notice it doesn't matter. But if I'm using the law of sine, I would be careful how I do this. And the reason for that, if you tell me that the sine of an angle is positive, well, sine is positive in two quadrants. I wouldn't know which quadrant you're talking about. But if you tell me that cosine of theta is positive, then guess what? Cosine is positive in quadrant 1 or 4. In quadrant 1, that angle is allowed. In angle 4, in quadrant 4, an angle cannot be bigger than 270 degrees. That's not even allowed. And if you tell me that cosine is negative, well, the same deal happens. That is, the angle is either in quadrant 2 or 3. There's no way it could be in 3. It must be at most in 2. So if I'm not looking for the ambiguous case, law of cosine is the way to go. If I want to use the law of cosine, it's a bit longer than the law of sine. So what I would end up doing, I would really use the law of cosine to find one of the angles and the law of sine to find the rest. If I'm using the law of cosine and I'm not looking for the two cases, I would say, you know what? 8 squared equals 5 squared plus 4 squared minus twice times 4 times 5, the cosine of A. And if I swap those, 2 times 4 times 5, the cosine of A equals 5 squared plus 4 squared minus 8 squared. And cosine of A would be 5 squared plus 4 squared minus 8 squared all over 2 times 4 times 5. And A would equal, and again, whether it's positive or negative, I don't have to worry about two cases. It turns out to be 125.1 degrees. And now that I know this, and since I know it's safe to use the law of sine or cosine, well, guess what? Now I could simply say, well, if I take the sine of B to 5, that should equal the sine of 125.1 degrees to 8. And the sine of B would equal 5 times the sine of 125.1 degrees divided by 8. And B will equal, I'm going to take the acute, I don't need to worry about one or two cases, 30.75 degrees. And I wouldn't even worry about the other case because I know this angle is opposite of 5. There's no way it could be obtuse. And to find the last angle, I could say angle A plus B plus C equal 180. Since I know what A and B is, I could say C equals 24.140.